This is R.D. Sharma Solution, Class 12, Chapter 10, Differentiability, MCQ, multiple choice question we are taking. Before we go ahead, let me tell you that in R.D. Sharma and other NCERT books, initially these questions are MC questions and the VSAQ questions. They're already being covered in the exercise, for example, 10.1, 10.2, of course, in VSAQ, very short answer question. So you need to watch all those and then you can be appreciating these solutions. Okay. I would request you to please go through all of it and then you'll understand this better. Let fx equals to modulus of x and gx is equal to modulus of x cube. Then, so all these options are asking for the continuity and the differentiability of these fx and gx. Just for a revision, let me tell you again that if any function is differentiable, that means it is a guarantee that it is continuous also, right? But if a function is continuous, then there is no guarantee that whether it is differentiable or non-differentiable. We don't know that. We have to check it. So those who want to do this question try themselves, they can just have a look and they can get a reference. And those who want to actually know how to solve this question, what will be the answer, you can just go along with me. So this is a function which we have been using a lot. We have been discussing a lot. This is the graph of modulus x. So when you take a ride on this route, there is no break. So this function is continuous. Okay. So this is continuous everywhere. But at this, you can say sharp turn, if you take left and right, then you will get two tangents with a different m, tan theta or slope. That means it is not differentiable at this point, at origin you can call. But modulus of x cube, how to do that? So this modulus x, I hope you'll be able to do by yourself. I hope. And modulus x is for you because you can just go through all these previous discussions. And by graph also I showed you that why it is continuous, why it is not differentiable. The sharp turn, sharp edge, that means that differentiability may not be there, but still we have to check with all the formulas and the expressions we have to actually do it. So modulus x, I hope this can be done by you guys. Now coming to this modulus of x cube, that we are definitely going to see. Well, it also is similar to the modulus x because it is just x cube, but it is inside modulus. So let us check it. The last one is incorrect because the modulus x is not differentiable. Okay. And modulus x, we have already talked about modulus x cube. Whatever is inside modulus, it will always give you a positive and a negative value. So that point where we have to check, if you go up, that is, it is going to be positive value. For example, x minus 1 modulus. So you just have to check whether when x minus 1 is equal to 0, it is x equals to 1. So when you go up 1, it's positive. When you go below 1, it's negative. Similarly, this gx, it will be positive x cube because it is just a modulus sign. So you have to put a positive when x is greater than or equal to 0 and negative x when it is less than 0. So how to check the continuity? Left hand limit and right hand limit both we have to take. So we have to put x as 0 minus h, x as 0 plus h. Okay. So essentially you have to put minus h and plus h. Then we will apply the limit. Please remember, limit 0 minus means, or some value minus means you are on the left, 0 plus or some value above it, if it has a plus, that means you are talking about the value on the right of it. So minus x cube we are using because we are less than 0, greater than 0, we are going to use the x cube. Okay. So in place of x, replace it by negative h. Now you can change the limit. The limit needs to be changed. It should be limit h tends to 0. Okay. So this is minus negative h. So limit h tends to 0. Here also limit h tends to 0. And minus of minus h cube. So it will be minus, because negative power of odd will always give you negative. Negative becomes positive. Right hand side also you get a h cube, that is applying the limit you get a 0. Okay. So left hand limit and right hand limit are same, and let us check the value at the of the function at 0. So where is the equality? It's x cube. 0 cube is 0. So left hand limit and right hand limit we have already checked now. And the value of the function at 0. So this is continuous, that we have verified here. Right? Now coming to the other differentiability part. So whatever we are doing, just keep an eye on the answer. Where it is continuous, where the function is not continuous or differentiable, non-differentiable. That's how you're going to give your answer or select your answer. Before we actually find out what is the exact answer, we need to check the differentiability also. So left hand derivative and right hand derivative we are checking. Okay. This x is 0 minus h, and this is x equals 0 plus h, that is h only. That we are going to put in x equals, because we are going to check at x equals to 0. So limit x tends to c, fx minus fc divided by x minus c. So x is 0, so in place of c, this is c equals 0. So wherever we have c, replace it by 0. Now we have to go to left hand derivative and right hand derivative, and you have to use the function accordingly. If you are below 0, you have to use negative x cube, this one. And if you are above 0, you have to use x cube. Okay. So f0, I told you already, f0 we have already checked just now in the continuity. f0 is 0 only. So minus x cube in place of fx minus fc, that is 0, divided by x minus c, that is minus h minus 0. So minus h you can replace here, but I'll just replace it. But let us see the right hand derivative also. Right hand derivative, you have to put an x cube, and then we have 0, fc is 0, f0 is 0, we already checked it. And no x minus c, in place of x you have to replace it by h minus c is 0, so it will be h in the denominator. So this is limit x tends to 0 minus, and the right one is limit x tends to 0 plus. But now we'll change the limit h tends to 0, we'll replace x by minus h in the left and by x as h on the right. So this is what you have to write everywhere. There is a point where the limit will change also. Now this is h cube by h. This gets cancelled. You have minus h cube, that is going to be minus h cube only, because it is odd power, and denominator you have h. So this gets cancelled. It will be minus h square. Here also it will be h square. And when you apply the limit h tends to 0, you are going to get a 0 on both the sides. This is 0 and this is 0. Okay. So left hand derivative and right hand derivative, they are matching. So you can say the modulus x cube is continuous also, differentiable also. Mod x is continuous but not differentiable. Accordingly, please choose the answer. The function fx equals sine inverse cos x is discontinuous at x equals to 0, continuous at x equals to 0, differentiable at x equals to 0, none of these. So see, differentiability needs to be only checked after you have checked for continuity. But if you have checked directly for differentiability, and if it is differentiable, you don't need to check it for continuity, because it will be obviously continuous. Alright. So we have this function fx equals sine inverse cos x. So you have to check at x equals to 0. This is given already in the question. So this is sine inverse cos x. So in here x equals to 0 you have to put. So left hand limit and right hand limit we are going to compute. Left hand limit, right hand limit. So we have to put x as 0 minus h in the left hand limit, x as 0 plus h in the right hand limit. So basically it is sine inverse cos 0 minus h. Here it will be sine inverse cos and 0 plus h. So sine inverse cos negative h, and cos minus theta is cos theta only. Okay, cos minus theta is cos theta only. And then we have sine inverse cos h. So cos h both inside. You can just apply this limit. Limit h tends to 0. Here also limit h tends to 0. And this is cos 0 is 1. So cos 0 is 1. So sine inverse 1 it will be. Here also sine inverse cos 0 is 1. Now sine inverse, what is that? Sine inverse theta equals, say x equals y. Let us see like that. So x will be equal to sine y. What is the value of y so that sine of it will give you 1? It is pi by 2. Sine 90 is what? It is going to give you 1. So the answer is pi by 2. Now you will say 1 can come in many cases. Okay. Sine 0 is 0, so it passes through the origin. And this 1 is going to come because this sine is never ending. It always oscillates between -1 and 1, but on the x-axis it is never ending. Okay. So this can be 2n pi plus or n pi plus, that you have to decide. So there can be multiple solution of this, but here we are just restricting ourselves to the first quadrant. Okay. So continuity we have already checked. LHL and RHL both were the similar value, and the value of the function at 0, which is sine inverse cos 0. Cos 0 is 1. Again sine inverse this 1 is pi by 2. So this is continuous. This function is continuous. We have already checked it. Okay. Now coming to the second part, which is the differentiability. So we have to check for the differentiability as well, and then we can decide what will be the suitable answer for all these options which are provided to us. So left hand derivative, right hand derivative. The function is fx minus fc by x minus c. Limit x tends to c. So c is 0 here. It is already given. f0 we have already found out. Pi by 2 I am going to directly put in here. So this is x equals 0 minus h. This is x equals 0 plus h. That is negative h on left and positive h on here. Right? So this is limit x tends to 0 minus, limit x tends to 0 plus. This just shows which function you have to put in. But we have to use fx, both the cases same thing, because fx is sine inverse cos x. So this is sine inverse cos. We just have to put 0 minus h here. Minus, as I already told you, f0 we have already done. That is pi by 2. So replace it by pi by 2. And then we have this as the denominator, and that is x minus c minus h minus 0, that is going to be negative h. Here also same thing, sine inverse cos 0 plus h, so you can replace it by h, minus pi by 2 because fc will remain there, and then in the denominator it is 0 plus h, that is h. So let us put it like h. Okay, now we cannot go ahead just like what we have done in continuity, because this cos theta you can always write it as sine 90 minus theta. So I am changing the limit h tends to 0, and this is also, see, we need to write this because cos minus theta is plus cos theta, so you can just write that as cos h. So we'll try to cancel this sine inverse and sine, because we know that cos theta is sine 90 minus theta, and cos 90 minus theta is sine theta. That we already know. So cos theta, you can write it as sine pi by 2 minus h, and in this cos h, in place of cos h, we are just replacing it, minus pi by 2. So you can just cancel these two out. Pi by 2, numerator I am telling you, pi by 2 minus h minus pi by 2, minus pi by 2 minus pi by 2 cancel out, and minus h by minus h, that is going to be 1. So limit h tends to 0, you have 1 here. Here also, same way we are going to go ahead, sine inverse. In place of cos, write sine 90 minus theta or pi by 2 minus h, minus pi by 2 divided by h. I'll just take it, sine inverse cancel, pi by 2 minus h minus pi by 2 is going to give you negative h. In the denominator, you have a h. So this gets cancelled, you have a negative 1. So the left hand derivative is 1, right hand derivative is negative 1. That is, they are not matching. When they are not matching, that means this function is not a differentiable, but it is continuous at x equals to 0. This is how you will choose a suitable answer from all these 4 options. The set of points where the function fx is equal to x into modulus x is differentiable. Differentiable where? Modulus x, you are completely aware by now. How this modulus function works for simple x, what is the graph of this function, we have been talking every time, okay? So mod x, just to revise, x is greater than or equal to 0, it is x. It is negative x when x is less than 0. So x into modulus x, you just multiply it by x. Will not change. So x into modulus x will be x square when x is greater than or equal to 0, and negative x square when x is less than 0. So x is greater than or equal to 0, x is less than 0, we've got the value. So these intervals, if you see, there is a 0 also involved. And because it is round bracket and square bracket both, so 0 is included somewhere, 0 is not included somewhere. So we have a closed interval and open interval as well. So what we have to do here is, if you just put 0 in place of this fx, f0, it will be 0 into modulus 0, which is essentially equal to 0 only, right? So what will be the final, I'm just dividing this. So x square when x is greater than 0, it is negative x square when x is less than 0, we don't have any doubt about it. But it is 0 when x is equal to 0, which we already checked just now. So x into modulus x, I divided into 3 parts now. Just below 0, above 0, and then on 0. So this minus x cube and x square, they both are polynomial. So this negative x cube and x square, they are polynomial function. They are continuous and differentiable in the interval from negative infinity to 0 and 0 to infinity. So we have to check the continuity and the differentiability. We just have to check differentiability, because the question is not asking about continuity. We just have to check for the differentiability. This x square, see, 0 to infinite, it will always be positive. You put any value in x, it is from 0 to infinity always positive. On negative x square, if you put any value from negative infinity to below 0, it will always be negative. Right? So if you take a number line, just to show you what we are intending, negative infinity to 0 and 0 to plus infinity, this is all okay. But we still have to check at 0, because we are not checking at 0 right now. We have a separate value which is 0 at 0. So at this point, whether there is some say sharp turn, sharp edge, or the graph is, say, taking a sharp angle theta differently, that is what we are interested in. So the left hand derivative and right hand derivative, fx minus fc by x minus c, limit x tends to c, this is what we are going to do, which we always do, right? So here we have, when we are from negative infinity to 0, we'll use negative x square. When we are from 0 to infinity, we'll use x square. This is by the function also. And this we are directly going to put at fx, and fc, which is f0, is already 0. That already we know. f0 is 0. This we already know. We have already checked it and showed it to you also. So minus x square minus 0 divided by x minus c. In place of x, you are going to put 0 minus h. So 0 minus h, 0 minus h minus 0 is minus h only. Here also same thing, x square, because x is greater than 0, minus 0 divided by, then we have x minus c, so 0 plus h minus c 0. So you have this as h only. So what do you get here? H. Now first you have to write limit x tends to 0 minus and then 0 plus on LHD and RHD. Then when you put h, replace x by 0 minus h or 0 plus h, then you have to change the limit to limit h tends to 0. That you already know. I am not writing it again and again. That you can just see the reference of solution which I always provide. So you have minus h square and divide this minus h square by h. Minus minus cancel, h cancel, you have a h. When you put h tends to 0, it becomes 0. Here also you have h square by h, 1h again, and limit h tends to 0. When limit h is tending to 0 or approaching 0, it is 0. So left hand derivative, right hand derivative, both are same. It is differentiable. And from where? It is differentiable at x equal to 0. It was already minus infinity to 0. It was differentiable and continuous. 0 to infinity also, but we have already checked at 0. So you have to include 0. So it is from negative infinity to positive infinity. You can safely say from negative infinity to positive infinity, it is differentiable. First option is the correct answer. Now fx is this function when x is not equal to negative 2. So when it is not equal to negative 2, you have to use this function. Otherwise, when x is equal to negative 2, there is a constant function which is 2. So you have to show whether it is continuous, not continuous, differentiable, non-differentiable. So we have to do it properly the way we have been doing it. Okay. The main thing here is the modulus of x plus 2. So when we have x equals negative 2, if you go left, you will get positive. You go right, you will get right. Go right, you get positive. You go left, you get negative. Right? So we'll start with the continuity and then we'll go to the differentiability. Since the modulus is involved and you already know what to do with the modulus when it is positive, when it is negative. So when it is not equal to negative 2, you have to use this because that is what we are going to use in the left hand limit and right hand limit. And since it is modulus x plus 2, I already told you the inside one, just put it as 0. Whatever value x comes, that is the point which decides whether the values will be negative or positive. Left, it will be negative. Right, it will be positive. I hope you got the idea. So on the left, you are going to use negative x plus 2. On the right, where are you going to use x plus 2. So fx is equal to, this is our function. And since we have to check at x equals negative 2. So let me just give you this function with all these boundaries. So it will be negative x plus 2 when you are less than negative 2. When you are greater than 2, then of course you have to use the function as x plus 2 as I explained. And modulus we are opening, that's why. So we have tan inverse x plus 2 here. And when x is equal to negative 2, then what? When x is equal to negative 2, it is already given as 2. So left hand limit and right hand limit we are going to compute. To find out, we'll have to check at x equals to negative 2. So x equals to negative 2 minus h we have to do. And x equals negative 2 plus h on the right hand limit. So when you go on the left, you just subtract a very, very small number that is called h, which will be eventually equal to 0. When you go up ahead on the right, you just have to add a very small value, very small h, and that is going to be your 0 of eventually. So this, when you start, you have to write limit x tends to 2 minus. That is to indicate that you are going on the left. Similarly, on the right, you have to write limit x tends to 2 plus in order to tell that I am going on the right. So 2 plus. But we know what is the function. When you go on the left, you have to use negative x plus 2 divided by tan inverse x plus 2. This is what you have to use. And when we go on the right, so positive function you have to use. So limit x tends to 2 plus. So x will replace just by minus 2 plus h and change the limit in the second step. But here you have to put x plus 2 tan inverse x plus 2. Now we'll replace x by negative 2 minus h. So this is going to be minus, in place of x is minus 2 minus h. So this gets cancelled, you get a positive h. So in the numerator it's only h. In the denominator it is x plus 2. So eventually it will be negative 2 minus h plus 2. 2 gets cancelled, negative h. So you have tan inverse negative h. And this is, you have to change the limit here, limit h tends to 0. So I just change the limit here also. You have to change the limit, limit h tends to 0. And this x plus 2, replace x by minus 2 plus h. So minus 2 plus h and 2 gets cancelled, h by tan inverse x plus 2. So you have tan inverse x plus 2. So x is minus 2 plus h. And then we have a 2 here. 2 gets cancelled, h is there. So tan inverse h it will be. Now please remember, sine minus theta is minus sine theta, tan minus theta is minus tan theta, tan inverse minus theta is minus tan inverse theta, right? Tan inverse negative theta is negative tan inverse theta. Also, sine theta by theta or tan theta by theta, limit theta tends to 0. This amounts to 1. This is equal to 1. So this is tan inverse h by h only. If you take h in the denominator, it will be eventually equal to that only. So this is applying the limit in the numerator denominator. So we can apply the limit in the denominator, assuming it to be tan inverse h by h. And since we have a negative h, so we have to take a negative outside. And tan inverse h by h, I'm taking the numerator into the denominator. Just to show you that theta by sin theta or sin theta by theta both amounts to, when you take limit theta tends to 0, both amounts to 1. So you have tan inverse h by h as 1. There was a negative because of the tan inverse minus h, so minus 1 comes. On the right, you see tan inverse h by h, same thing, tan theta by theta, tan inverse theta by theta, that is going to be 1. When the theta tends to 0, so this is going to give you 1. So negative 1 and 1, so they are not equal. That is, this function is not continuous. So when it is not continuous, why would you check for the differentiability? You won't. Okay, this function is not continuous, so just write it is not continuous at x equals to negative 2. Let fx is equal to x plus modulus x, or the absolute value of x, multiplied by modulus x or absolute value of x. So please remember, there are 3 things being asked: f, f dash, and f double dash. So 3 kind of differentiation we have to do. We are in the chapter of differentiability, so we don't have to we have to worry about how did we can solve, or how are we going to solve the question of differentiation, because this is not the chapter of differentiation, this is just differentiability. But since the question is asking about f dash and f double dash, we have to differentiate. So I'll give you an idea. F dash we have to find out, f double dash as. You can see f is continuous, f dash is continuous, f double dash is continuous. 3 options are there. One more option is there. F is differentiable for some x. Right? So let us see the continuity. First let us talk about this function. I'll tell you about this function. How are we going to actually find out the final value of this function? When we have to deal with the modulus x, it becomes somewhat tricky. So we have x plus modulus x into modulus x. Multiply this modulus x inside, so you get x into modulus x plus modulus x into modulus x. It is going to be modulus x whole square. So we have this modulus x whole square will always be x square. Modulus x is x when x is greater than or equal to 0. It is going to be negative x when x is less than 0. But when you square it, modulus square, it is going to be squared here also, x square and negative x whole square. So x square and negative x square both will be x square eventually, right? So this is going to be x square, modulus x square is eventually equal to x square only. So you can just write it as x square, because when you square the negative, it will always be positive. So what do you get? X into modulus x plus x square. Okay. Now let us find out and write the proper fx. The proper fx will be only dependent on the modulus which is left here. So modulus x, again x when x is greater than or equal to 0, negative x when x is less than 0, right? So we'll write it here, x into when x is greater than or equal to 0, this modulus x will be negative x, positive x. When x is less than 0, it is going to be negative x. So just replace this modulus x by negative x. Okay. So this is x into x will be x square plus x square is 2x square. So x is greater than or equal to 0. X is less than 0. What do you get? X into minus x is minus x square plus x square. These both gets cancelled. You get a 0. So fx, this is the final f function which we have to use. Please remember, we have to do the f dash. We have to do the f double dash also. That is double differentiation we have to do. 1, 2, 3. 3 steps we have to go. So this function I am going to use again. I am just clearing it. So then we'll start with the continuity of all these. Okay. So left hand limit and right hand limit, that we have been doing up till now. And left hand limit and right hand limit for what? Of course 0, because modulus is all dependent. When it is simply modulus x, it is all dependent on 0. When you have modulus x plus 2 or x minus 3, that amounts to some other value, where on left and right you will go differently. So here we have this 2x square. When you go on right, you will have 0 when you go on left. So x is 0 minus, that is saying that we are going on the left of 0. And then you have to write, when you are going x less than 0, I told you it is 0. When you go on the right, it is going to be 2x square. So please remember, when we apply this 0 minus and 0 minus h and 0 plus h, when it is the result of division by 0. For example, 0 raised to 0, 0 by 0, infinite by 0, whatever it is. It all boils down, or it all comes down to the division by 0. So whenever we have something of division by 0, then we apply the L'Hospital rule, or then we apply 0 minus h, whatever is suitable to us. Okay. 0 minus h and 0 plus h is only applied there. You can apply it here also. But since I know that I am not going to get any value of division by 0, so I can apply directly here. So just apply x as 0 in both left hand limit and right hand limit. So 0 on right hand side also, 2 into 0 square is 0. So left hand limit and right hand limit both are same, so f is continuous. You have to find out the value of the function at this 0 also. So when you apply this f0, you will see that value also will be, because 2x square, 2 into 0 square, that is again 0. And what about the differentiability? Fx minus fc by x minus c. Limit extends to c. This is the formula we apply. Or this is the, you can say, the precursor of the first principle. The left hand derivative, right hand derivative, you go to the left, you will use fx as 0. 0 minus, right, on the right, it will be fx will be 2x square. So let me just complete this fx first, then I'll write the other values. So when you go on the right, it is going to be 2x square. So you can just write 2x square in this place. 2x square here. Okay, what is fc? What is f0? I just told you. f0 is what? Just put the value of 0. What is the equality? 2x square came when x was greater than or equal to 0. So it is the equality. 2 into 0 square is 0. So fc is 0. f0 is 0. Divided by x minus c. X, you can keep x like that, because we are not replacing it by 0 minus h or 0 plus h. But c, of course, we are checking at 0, so c is 0. So x minus 0 here. So eventually what do we get? Final one. 0 minus 0 is 0, 0 by x, so it is going to be 0. You know, this is 0 on the left, and then when we apply this one, 2x square by x, x gets cancelled, apply x as 0, so 2 into 0 is going to be 0. See, I have not used h here. So the left hand derivative and right hand derivative both become 0. So when you say that left hand derivative, right hand derivative both are 0, you can easily say that this function f is differentiable at x equals to 0. Not at some x. The option given in your question is f is differentiable for some x. But we are talking about it is only differentiable at x equal to 0. Other points we don't know. So the second option cannot be true. First is true, that we have already checked. Now there are two more things, f dash and f double dash. So I am clearing it again. Now we are going to f dash. So let me write function again fx. And f dash, why we are finding out? We have to take the differentiation of this. So 2x square differentiation is 2 is a constant, so it won't be differentiated. And x square will be differentiated, x square will be 2x. So 2 into 2x is 4x. Again, let me tell you, this is the chapter of differentiability we are doing. F dash has and f double dash has nothing to do here. That is the proper differentiation has nothing to do here. Okay. But since we are given the question, f dash will be 0 for x less than 0. 0 of differentiation of 0 is 0 only. Now we'll check the left hand derivative and right hand derivative, or you can say the left hand limit and right hand limit of the derivative. We checked it for fx. Now we are checking it for f dash x. So limit x tends to 0 minus, here limit x tends to 0 plus. Okay. So 0 minus means you are going on the left, that is you are going to use function as 0. When you go on the right, you have to use the function as 4x. Okay. So let us see here. You have a 0 and 4x. Now you can just apply limit directly because there is nothing of 0 divided division by 0 form. So 0, 0, when you apply x as 0, left hand and right hand both are 0. That means the f dash is differentiable. When it is differentiable, it will be continuous also. F dash 0 also will be 4 into 0, that is going to be 0. So these all value, left hand limit and right hand limit and the value of the function at 0 for the f dash x or the derivative of this function fx, all the trio, all the three things are coming same. So they are differentiable. When it is differential, it is continuous only. Right? I hope you got the idea. Now we are not stopping here. We have to do it for f double dash also. So f dash x, this is continuous. I'm just, there may be some mistakes here and there. So you just have to forgive me for that. So this is continuous at x equal to 0. Right? All are coming 0. Now coming to the f double dash x. F dash is continuous. Yes, you can say. You can say that f dash is continuous. Because once you have checked the differentiability, you can always say that f dash is continuous. Because the continuity is not the guarantee of differentiability, but the differentiability vice versa is the guarantee of continuity. Right? Okay. So f is continuous is correct. F is differentiable for some x is not correct. F dash is continuous. We have checked it out. It is correct. Now coming to f double dash x. So we have to differentiate it again. We started with the function 2x square and 0. Then we said 4x and 0. Now third one is f double dash x, which is again the differentiation of 4x and 0. This one. Again a differentiation of this one. So f double dash x, let us take the differentiation of this. So 4 into 1, that is 4. 0 is 0. So x is greater than or equal to 0, it will be 4. X is less than 0, it is going to be 0. Right? So this is the left hand limit and right hand limit for the second derivative. X is 0 minus, x is 0 plus, and even if you apply h or whatever, it doesn't matter because this is a constant function. If you go on the right, it is always 4. When you go on the left, it will always be 0. So 4 and 0, whether you apply limit or not, it won't affect. 0 and 4 are the final values. They are not matching. So the left hand derivative and right hand derivative of the derivative f double dash x is not coming equal. So it is not continuous, it is discontinuous. So what is the answer? F is continuous, F dash is continuous. Okay. The function fx is equal to e raised to the power negative modulus x. So there are different options here, and we will try to check the trivial way. We will just first eliminate the modulus, then we'll do the LHL and RHL, then we'll do LHL and RHL for the derivative. That's what we are going to do. So modulus x is x when x is greater than or equal to 0. It is negative x when x is less than 0. By now you might have mugged it up. You have been feeded with this modulus x number of times. So when x is greater than or equal to 0, replace modulus x by just x. So it will be e raised to the power minus x. When x is less than 0, you have to replace modulus x by negative x. So it will be e raised to the power minus of minus x. So you get x greater than or equal to 0, e raised to the power minus x, and x less than 0, e raised x. So there is a slight correction in the answer which I have provided you on the right solution. So there is a slight correction. Okay, this will be the final verdict. Okay, so this is what you get while you remove, or you can say you solve the modulus x. This final, so I'm just changing this. X greater than or equal to 0, it is e raised negative x. So you have to remember, because I'm gonna do the derivative also in a short while. First we'll do the left hand limit and right hand limit. So this is the number line, just to show you that we are at 0. On the right we are going to use e raised minus x. On the left we are going to use e raised x. Okay. Now what you can do here is you can replace this x equal to 0. Of course, when you are doing it x as 0 minus and limit x tends to 0 plus, you are just telling that I am going to take the left function, or the function which is when x is less than 0. So e raised x you're going to use, and when you are x tends to 0 plus, you will use the function on the right. So e raised minus x. Since you can always write x as 0 minus h and 0 plus h, but I know and we know that if I replace x by 0, we are not going to get any untoward, indiscriminate, undescribable value. That is, anything with division by 0 is a cause of concern. But we don't have any concern here, because e to the power anything will not give you any untoward result until it is 1 by e raised to the power infinity. Okay. So anything to the power 0 is always 1. So e raised to the power, when you apply the limit e raised to power x, that is e raised to the power 0, you get 1. Here also, when you apply this x equals 0, so e raised to the power of minus x is 1 by e raised to the power x, and when you apply this 1 by e raised to 0, you get 1 by 1. So left hand and right hand, you see both are giving you 1, and the value of the function at 0, that is, if you actually put fx equals to e raised to the power minus x for x greater than or equal to 0, you get the value f0 as what? This is equality. So e raised to the power minus 0, that is going to be e raised to the power 0. 1 by e raised to the power 0, 1 by 1 is 1. I hope you got the idea. The left hand limit and right hand limit and the value of the function at 0, all these three are same. So the function is continuous at x equals to 0. That is being established right now. We are going to check for the differentiability. Now the second step is the differentiability. So left hand derivative and right hand derivative. Okay. There are multiple ways to solve it. Most of the books and solutions, they have given different solutions. But we'll go by the way we have learned, fx minus fc by x minus c. Fx is of course the function which I told you on the left and right what you have to use. So fx minus 1, fc is 1 because f0 is 1, I just showed you. X minus c is of course 0 here. So this fx minus 1 by x we are going to use. Final one is this, that we can always use on the LHD and RHD. So x 0 minus h you can put, x as 0 plus h you can put here. So the function will be on the left, you are going to use what? When you are x less than 0, e to the power x. As I told you in the beginning, the function is e raised x on the left, on the right it is e raised to the power minus x, right? Okay, so we will put 0 minus h and 0 plus h, and they will try to find out or use a certain identity or already established result. So e raised x here, e raised minus x here, e raised minus x here, e raised x minus 1 by x, e raised minus x minus 1 by x. So what is this? Limit x tends to 0 minus here, limit x tends to 0 plus here, and now replace it by 0 minus h and 0 plus h. So you have to change the limit. Limit will be limit h tends to 0. E raised 0 minus h is minus h only, 0 plus h is h only. So e raised to the power 0 minus h, that is minus h minus 1, and negative h in the denominator. On the right hand derivative, it will be limit h tends to 0, e raised to the power h you have to replace, so minus h, minus 1 by h is h only. Okay. Now please remember, e raised to the power x minus 1 by x, limit x tends to 0 is 1. That we already know. We have used it. Log version, e raised x version, we already know. E raised x minus 1 by x, limit x tends to 0 is already 1. That we already know by our previous classes and our experience. Here we have on the left minus h and minus h, so you can assume it to be x. Here you have minus h, but in the denominator you don't have minus, so I am introducing on the right hand derivative negative. Here you have e raised x minus 1 by x form, so it is, when you apply the limit it will be 1. Here you have e raised x minus 1. So we have introduced a negative, so now this becomes 1. But there is a negative also, so it will be negative 1. So you have 1 on the left, negative 1 on the right. So left hand derivative and right hand derivative. What did we get? One is coming as 1, one is coming as negative 1. So they are not matching. So the function is not differentiable at x equals to 0. Though it was continuous at x equals to 0, it is not differentiable at x equal to 0. Okay. So the option will be, the answer will be, it is continuous everywhere but not differentiable at x equals to 0. This is a solution. I don't know, there are certain solutions which are not correct. So I just want to put it here so that you do understand that all the solutions are not correct. You have to follow the rules and the regulations of mathematics. The in-depth study will give you that thing. All these solutions which are everywhere may not be correct always. Now we will be talking about the cos x modulus and sin x modulus. There will be question. We have discussed it, but I will give you a brief explanation of that, but this will take later. So this question, fx is equal to under root of 1 minus under root 1 minus x square. Then fx is, there are multiple options being given. And please note that the options are negative 1 to 1 and 0. So when you have a function like this fx is 0 when? That is how we decide where to check. So when you put x equals to 0, what do you get? 1 minus under root 1 minus 0. So under root 1 is 1 only. And 1 minus 1 is again 0. So under root 1 minus 1 is 0. And under root 1 is 1. So 1 minus 1 is 0 and under root 0 is 0. That means this function will be 0 at 0. So we have to check at x equals to 0. Right? Please remember, whenever we check at that point where the function is getting 0, if we are not provided any limit or any boundary, first thing is whether this function is valid or not, that you have to check. And since we know if this function is valid and if it is a polynomial or any kind of what we have learned, any kind of type of that, then we can safely say it is continuous. But we have to first verify and find out that it should not be negative inside a root. So a normal function will not be like this. If you have under root negative, that will be a complex function or complex kind of mathematics. So we will not talk about that. We just consider that there should not be anything inside root which is negative. So 1 minus x square inside the root should not be negative. So 1 minus x square should be greater than or equal to 0, right? It should be greater than or equal to 0. That means x square should be greater than or equal to 1, and that is negative and positive. Whatever the value is there, the square should be greater than or equal to 1. Okay. So how to solve this inequality? You can just add x square on both the sides. This gets cancelled and you have x square which is less than or equal to 1 is coming. X square less than or equal to 1 means x, see, this is equivalent to modulus x. Please remember, x square less than or equal to 1 is equivalent to modulus x. That is, if you put negative x or positive x, that is going to be less than 1 only. It can be negative, positive, both. So how will you decide what will be the range? What is the boundary? I'm indicating modulus x because this modulus x will be using in a short while in another question. So you need to know this x square is somewhat equal to that modulus x. Modulus x, as I'm saying, this is equivalent. So x is less than or equal to 1, negative x is less than or equal to 1. You can square it also. If you square it, it will be x square less than or equal to 1. Okay? I hope you got the idea. So x is less than or equal to 1 and negative x is less than or equal to 1. So you can multiply both sides by negative. So the equality or inequality sign changes. So x is less than or equal to 1 and x is greater than or equal to minus 1. So now you got the boundary. And that is how the question 4 options is also showing you negative 1 to 1. That is how the negative 1 and 1 has come. So x is in between negative 1 and 1. That is valid in the question, and that we have showed also. And since we know that equivalent solution for the modulus x, since it is differentiable, we don't know or will not talk about differentiability of that, but we know that this function is a continuous. So when you have a function like this, and this function, when we can define it for the legal values between negative and 1 to 1 that I already showed, this function is continuous. Now we'll go to the differentiability. Okay. So limit x tends to c. This is how we write. Limit x tends to c. This c is 0 here because we have already checked that this function will be 0 at 0. So fx minus fc divided by x minus c. What does it mean? Fx is what? This function. Okay. We'll use this function. And in place of left hand derivative, we will replace this x by 0 minus h, which is equivalent to negative h. And this one on the right, if you just see that will be replaced by 0 plus h, which is equivalent to h. Okay. Fx, we will directly put these function value and then we'll replace x by minus h and plus h depending upon when we are taking the LHD or RAT. So I already told you f0, we have already checked it. f0 was 0, remember? So in place of fc, which is f0, we'll put as 0. X minus c, c is 0. So this is division by x. So we'll use this simplified version fx by x in both the cases. One time it will come as negative h, one time it is come as positive h in the denominator. So 1 minus under root 1 minus x square. I'm doing this only, left hand derivative. You'll understand what will be the right hand one. So I'm replacing it by negative h now. The x by negative h, please remember you have to write limit x tends to 0 minus, then you have to replace x by 0 minus h, then you have to replace the limit by limit h tends to 0. Okay, that you will do. What I'm doing here is, so I'm replacing x by negative h. So limit h tends to 0, this means what? I am replacing x by 0 minus h here, so minus h here, under root 1 minus negative h whole square is h square whole square. That was the whole discussion just a few minutes back. Now divided by what will be this? Negative h. It is negative h. Please remember it is negative h. I'll just correct it. So can you resolve it? You can try it. You can try rationalizing it. But I'll show you that when you multiply this by 1 minus under root 1 minus h square, because you have to get rid of the under root. That is how you have to do. If you want, you can multiply it by plus. Okay, you can multiply by plus so that will also not solve the issue. So you're not getting anything. right? So the only thing is you have to put h as 0. We tried, but we failed. That is, we tried to simplify it so that h can be cancelled. But here you have under root 1 minus, I'm replacing h by 0. So you get 0 in the numerators. H is in the denominator. So negative h or h, it doesn't matter. 0 by 0, and this is the infinite. That is not describable. You cannot describe it. Similarly here on the RHD also you will see when you put h as h plus h, same result will come. Almost same, because it will be negative 0 by 0. One time it is plus 0 by 0. So it will be negative infinity and infinity. So infinity is not known to us. It is not, you cannot describe infinity. In Ramanujam series we have seen 0 by 0 is 1, but that is incorrect. In mathematics, 0 by 0 is undefined. Please remember. In Ramanujam theory or the web series, you can find it out that if you have a similar number, numerator, denominator, it is 1. But it is not. Okay. So not defined. So when the function is not even defined, if you want to take derivative, how can you say it is differentiable? So this function is not differentiable at x equals to 0. That is our final verdict. Okay. So you have to see that negative 1 till 0, 0 not inclusive, it is okay. From 0 to 1, 0 not included is okay. So you can say that from differentiability can only be between minus 1 to 1 without 0. Okay. So the option correct is differentiable on negative 1 to 0, union 0 to 1. But it was continuous at negative 1 to 1, that we already showed you. So this is differentiability. You have to strongly say it is not at 0. So round bracket, that is we are not including 0. But square bracket for negative 1 to 1, that I already showed you that this function is continuous between negative 1 and 1. Okay. So the answer is what? This is the B is the answer. If fx equals to a modulus of sin x plus b e raised to modulus x plus c modulus of x cube. Now I can tell you the answer. The answer is in front of you also. That is not a problem. But the problem here is the interpretation of modulus sin x. When I told you about modulus sin x in the previous discussions, you have already seen that the negative and positive depend upon whether it is a multiple of n pi or not. That is, if I make a graph, just to make you understand, if this graph is passing through like this, sin 0 is 0 and sin 90 is 1 and sin pi again 0. So it oscillates between 1 and negative 1. So from 0 to 1 it is positive, from 0 to negative 1 it is negative. Modulus x means what? This negative part should not be there. It has to be taken on the positive y-axis, right? Okay, that is what we do. This modulus means this here. So 0, pi by 2, pi, then you have this 3 pi by 2 and then we have your 2 pi. That is how it works. So at 0, pi, 2 pi, that is n pi, the sin x is going to be 0. But when it will be positive and negative, just above n pi and below n pi, you can say that. The whole interpretation is, or discussion is, sin x modulus cannot be discussed here. We will blind our eyes, we'll close our eyes and we'll do the way the question asks us to do. I hope you got the idea. I am saying this modulus sin x has a different interpretation. You cannot just open the modulus just like that. It has to include n pi and all the other factors. But now I am blinding my eyes and I just know that modulus y or modulus of anything is plus y depending upon when y is greater than or equal to 0 or y is less than or equal to 0. Number 9, if you go left it is negative, if you go right it is positive. So I will treat modulus of sin x exactly like this, not as n pi here, just because the options being given, the options which are provided here is not talking about n pi or 2n plus 1 pi by 2, whatever. Okay. So what we will do here is, we will simply say modulus x is x when x is greater than or equal to 0. It is going to be negative x when x is less than 0. That is what we are going to follow to solve this question. Okay. We'll apply a L'Hospital rule also. That is the differentiation of numerator and denominator. That is inevitable in this question. We have to do it. So when x is greater than equal to 0, all will be positive. A sin x plus b e raised to the power x plus c modulus x c x cube. This is fx. When x is less than 0, then just take negative. Minus a sin x plus c sin minus theta is minus sin theta. Please remember, but we are not talking about sin modulus x. We are talking about modulus of sin x. So it will be minus a sin x plus b into e raised to the power negative. This is negative x, okay? And then minus, because x cube, it is a odd power. So when you take the negative of negative 1 and odd power, it will always be negative. So it will be negative cx cube. Negative cx cube. Please remember, I just miss c. You just assume that there is c. Okay. So we will find out the differentiability. This function is asking about differentiability. So x equals to 0, we'll check the differentiability. We'll take the left hand derivative. We'll take the right hand derivative at x equals to 0. So fx minus fc divided by x minus c, limit x tends to c, is what we use. See, okay? Fx what we'll use on the left, that is x less than 0, this lower one, and x greater than 0, this upper one. This we are going to use. This function on left and right. And you will put x as 0 minus h in the left hand derivative, and you have to put x equals to 0 plus h in the right hand derivative. Since we are on the derivative, we can apply the L'Hospital rule. Remember, L'Hospital rule is differentiating numerator and denominator together in order to solve the question. What is f0? When you apply 0 in this x greater than or equal to 0 function which we just found, you say a sin 0 plus b raised to the power 0 plus c into 0 square. So this a sin 0 is 0. Here only b will remain, and here c into 0 is 0. So only b will remain. So fc is b. f0 is b. Okay? f0, which is fc, c is 0 in this case, because the function is getting 0 there, or you are getting a b there. You have to check at 0, so the function is not getting 0, but it has a b. So fx minus b divided by x, because c is 0 here. So final simplified version is fx minus b by x. Now we have to replace x by 0 minus h here on the left hand derivative. We have to replace x by 0 plus h in the right hand derivative. So I am now replacing minus a sin minus h plus b e raised to the power minus of minus h minus, in place of x, minus h whole cube. Minus b is also there. Divided by 0 minus h, that is negative h. Okay. Sin minus theta is minus sin theta. So this becomes positive. You get a sin h. And then you have b raised to the power e to the power minus of minus h. Minus minus gets cancelled. You will only get b raised to the power e to the power h. And here you have negative h whole cube. That will be negative h whole cube only. When you apply the cube on the negative, it will be negative. Negative becomes positive. So it will be positive of h cube. CH cube. And you have a negative b also. Right? And in the denominator, you have negative h. Let it be negative h. On right, what we get, we will just replace h by the x by h. So it will be a sin h. Please remember, we are taking x greater than or equal to 0 here. A sin h plus b e raised to the power h plus c h cube. And minus b also, because fx minus b by x. X is h. So h we are replacing. Okay. Now we are stuck. There is no x common. And since it is the function is differentiable at x equal to 0, the function is already given. The question is saying that. So we have to equate the left hand derivative with the right hand derivative. So a sin h plus b e h plus c h cube minus b by h, and left also we have something like that. We will not be able to solve. So we have to apply certain rules so that we get rid of some or the other thing. We can simplify it. So we will apply the L'Hospital rule, which just says if some where you are stuck, you are not able to solve, try differentiating the numerator and denominator. This is not a differentiation question, but there is no option other than to apply the L'Hospital rule. Okay? So we will differentiate the numerator and denominator together. Okay, a sin h is cos h plus b e raise h is e raise h plus this becomes 3ch square by minus b, this is a constant, this becomes 0. We wanted to get rid of minus b and this is how it is possible. And we have a negative h, d by dh we are doing, so it will be negative sign will be there, h differentiation with respect to h is 1. Right hand side also a cos h plus b e h plus 3ch square. Same thing, 3ch square minus b will be 0 because we are differentiating. Denominator is what? Differentiation of denominator with respect to h is going to be 1. Now apply the limit now. You can apply the limit. Cos 0 is going to be 1. So let me write it. A, and then we have e raised to the power 0 is 1. So you get b. And since we have a h here, so this becomes 0. Here also you have a negative 1 in the denominator. 1 in the denominator on the right hand side. Cos 0 is 1. So you get a. And this e raised 0, you get b. And the ch square, h is 0. So you can just strike it off. So negative here. So you can write it as negative a plus b. And since differentiability is at x equal to 0, you have to equate them, these two. There will be equal. Take negative a plus b on the right hand side, it will be positive a plus b. So you get 2a plus 2b equals 0. You can take 2 common, you get a plus b equals 0. So a plus b equal to 0. When a plus b will be equal to 0? You see all the options? When a and b both will be equal to 0. When a is equal to 0, b is equal to 0, you will get a plus b equal to 0. This is your option. First is incorrect. Second option is the correct one. So you can say that this is the answer. Okay. See, this particular differentiability chapter, this question should not be asked. But since in your examination any question can be asked, you have to know about differentiability and differentiation together, L'Hospital rule. All these are, you can say, the rows of a bunch. We have a series here, fx is equal to x square plus x square by 1 plus x square, like this. So there are 4 options. Who wants to do by themselves? For them I have given a reference. And those who want to understand the logic, just see that. Let me write this series and put value 0. Because the function is asking at x equals to 0. The question is also talking about 0. So I am putting x as 0 everywhere. 0 by 0 square plus 1 plus 0 square, that is going to be 0 by 1, that is going to be 0. So all zeros will be there. So it goes up to infinite. When you add this, f0 will ultimately give you a 0 value. When you apply limit extends to 0 on fx, if you want to check the continuity, the limit on this function for this c or any value which needs to be checked, if this is equal to the function value at that value, that is, you have to check at 0. So f0, if it is equal to limit extends to 0 fx, then you can say that this function is continuous, otherwise discontinuous. f0 we just found out it is 0. So let us see this. I am taking x square common from this series. When I take x square common, what is remaining? 1 plus, you have 1 by 1 plus x square. Then we have 1 by 1 plus x square whole square. And this goes up to infinity. Right? Now I am applying the limit extends to 0. And you know that when you have the form like this, you have a series here. For example, you have a plus a square plus a cube like this. Then what is the sum of the infinite series? It is a upon 1 minus r. The r is a common ratio. A square by a cube by a square, a raised to the power 4 by a cube, like that. This is just I am giving you an example. So this example can be employed, or this result can be employed, which we have learned in the series, geometric series and arithmetic progression, all these. So we have a by 1 minus r, a is 1 here, 1 minus r. If you divide any of the two terms, you get 1 by 1 plus x square. This is your r, common ratio you can call. So I'm taking only the right portion right now. I'm just solving this, then I will apply the limit, etc. So 1 minus 1 by 1 plus x square. So 1 plus x square here, minus 1 divided by 1 plus x square. So 1 gets cancelled. You have x square by 1 plus x square in the denominator. This is in the denominator. When it goes up, 1 plus x square will be in the numerator, x square will be in the denominator. Now this x square was already there outside, so you just cancel these two, x square and apply the limit. When you apply the limit x tends to 0, 1 plus 0 is going to be 1. Alright? So when these two are equal, f0 is equal to 0 and this limit is actually coming as 1, so they both are not equal. So when the initial criteria failed here, so you can just clearly say that this function is discontinuous. Now if you go to the multiple choice question, question number 7, we have already discussed this question. So if you have seen that MCQ, you have watched that, you can just skip and go ahead. And for those who want to do this and try to learn in detail, they can refer to multiple choice question chapter number differentiability and question number 7. But I'll give you a hint here, just an idea. See, y is equal to log x. This is the graph of the log x. You have to be very careful about log x because this is just an exponential function. But this varies. This varies in negative and positive both. So if you are from 0 to 1, see, log 0 is not defined. So this graph is never going to touch the y-axis. So it is from 0 to 1. When the graph is between 0 to 1, you can see it is on the negative y-axis. From this graph, it is clear. So log x, if you open the modulus, it will be negative log x for the value between, this x should be between 0 and 1. Please remember 0 is not included here. But when you go up 1, when you move ahead 1, then you see this graph is positive, so you get it on the positive y-axis. So for that, when you open the modulus, you will get a positive log x. I hope you got the idea. So you have f dash 1 plus, f dash 1 minus. This is the first option and second option. It is not seen here, but the options are 1 plus and 1 minus. So we have checked the continuity, we have checked the differentiability for log x, if you remember. But since the question is asking about f dash, that is the derivative or differentiability, and since they have given the option 1 plus and 1 minus also, so we'll check at x equals to 1. We will check we will demonstrate the differentiability at x equals to 1. So left hand derivative, when you go on the left hand of 1, you have to use negative log x. And the right side you have to use log x function. The differentiability is given by fx minus fc divided by x minus c. X is tending to c and c is 1 here. C is 1 here. So fx, both functions you know, minus log x and log x, that you know already. What is fc? Just put f1 here in the equality sign function. Log 1 is 0. So if you take log 1, it is going to be 0. So fc will be 0. So we are not going to use it or write it because we already know it is 0. So fx minus fc is basically fx we are going to write. fc is 0. So this fx minus 0 divided by x minus c. X minus, what is c here? As I said, we are checking at 1. So x minus 1. So finally, the simplified version of this fx minus fc by x minus c is fx divided by x minus 1. I hope you got the idea. That we are going to use in the LHD and RHD both. The only difference will be the function. So when you are from 0 to 1, that is on the left of 1, you are going to use negative log x in place of fx. Okay? And log 1, of course, as I said, it is 0, so I am not writing it. This log 1 I am talking about. It is 0, I just simplified the function x minus 1. So x minus 1. Because we are taking x tends to 1 minus. When you are at x tends to 1 plus, then you have what? Log x divided by x minus 1 again. So x will be equal to 1 minus h, x will be equal to 1 plus h on LHD and RHD, and then we'll change the limit. Now limit will be now h tends to 0. Here also limit will be h tends to 0. And this is going to be replaced 1 minus h in place of x. So minus log 1 minus h divided by x is 1 minus h. So you have 1 minus h minus 1. 1 minus h minus 1 minus cancel, you get a negative h. Here you have log 1 plus h. So just write log 1 plus h in place of x, replace it by 1 plus h. 1 plus h minus 1 is h. 1 plus h minus 1, 1 gets cancelled, you get a h. Please remember, log 1 plus x by x, limit x tends to 0, is always 1. That we have used multiple times. Since it is negative h, you can directly use negative h in the denominator. It is almost equivalent to the identity I showed you. Negative is outside. There is a separate negative here. So you get a negative 1. Log 1 plus h by h, this also gives you 1. So you have a negative 1 here, you have a 1 here. So f dash 1 plus is 1. F dash 1 minus is negative 1. Okay. So the answer is A and B. I hope you got the idea. 1 plus is 1, this one. And then we have two options for negative 1. So you are not going to choose the last option because it is just saying f dash 1. But we are talking about f dash 1 plus and f dash 1 minus. F dash 1 plus is simply equal to what are you going to get in the right hand derivative. Similarly, the left hand derivative will give you f1 minus, f1 plus and f1 minus. So f1 plus of course is 1. But we have two options for 1, 1. There are two options which are saying 1. We are not going to choose the third option. Same logic goes for f dash 1 plus, which is equal to negative 1. And we also have f dash 1 as negative 1. That also not we are going to use. We will use the second option, which is f dash 1 plus. Okay. I hope you got the idea. But if you want to know this in detail, because we have covered the continuity of this question also, then you can always refer to the multiple choice question number 7, where we have discussed continuity about, and not only continuity, the function graph. We have made the graph and we have analyzed it, and not only on the positive part but on the negative x-axis also. Okay, this question again, it has taken us more than 15 minutes to discuss. In question number 9 of exercise 10.2, I'll give you the link of the whole playlist. I would request you to please refer to 10.2 question, because we have discussed this in a great detail, how this log x, log modulus x and modulus of that log x, how does it unfold? Okay. Now fx is equal to 1 by modulus x for modulus x greater than or equal to 1. Ax square plus b for modulus x less than 1. Now the question is saying this fx is continuous and differentiable also. So you have to find out the value of a and b. So modulus x less than 1 means what? And modulus x greater than or equal to 1 what? Modulus x greater less than means x is less than 1 or a negative x is less than 1. So negative x less than 1, multiply both sides by negative, so the sign, the inequality will change. So x is less than 1 and x is greater than minus 1, that is what modulus x less than 1 says. So in order to understand it graphically, you have a negative 1 here, you have a 1 here. So anything between negative 1 and 1, where my negative 1 and 1 are not included. Okay, that means it is modulus x less than 1. So now you are talking about modulus x greater than or equal to 1. What does it mean? It means you are talking about values which are less than or equal to negative 1. Same thing what we have done for modulus x less than 1, you can also do it for modulus x greater than or equal to 1. Modulus x greater than or equal to 1 means x greater than or equal to 1 and negative x greater than or equal to 1. And that will give you x is either less than or equal to minus 1 or x is either greater than or equal to 1. For x greater than or equal to 1, you will get 1 by x. For x less than or equal to negative 1, you will get negative 1 by x. So we have three boundaries. One is negative infinity to minus 1. The other is 1 to infinity and the other is negative 1 to 1. So I am doing the modulus x greater than or equal to 1. that is x is greater than equal to 1 and negative x greater than equal to 1, it may be both are there, because when you open modulus x, it will be the negative x greater than equal to 1, you multiply both sides by negative sign. So it is going to be x is less than equal to negative 1. You know the inequality change when you multiply by the negative sign. So you are talking about negative 1 and left, 1 and right. So when you go up 1, you will get 1 by x. When you go below negative 1, you get negative 1 by x. Okay. So we have a function modulus x greater than equal to 1, which is actually saying as greater than 1 or less than minus 1. And since we have a 1 by modulus x, one time you will get 1 by x, one time you will get 1 by negative x. Right? 1 by x when you have x greater than equal to 1, you will get 1 by x when x is greater than equal to 1. You will get negative 1 by x when you have x less than equal to negative 1. Please remember, I told you, I explained you already. And ax square plus b, if you have x between negative 1 and 1. So you have all the areas covered now. So depending upon at which value you have to check, you will use this function accordingly. This function, you can add 1 by x when x is greater than equal to 1. Okay. Let us see how it turns out to be. So I'm just cleaning it up. I hope you got the explanation now. Now it is easy to solve. Now it is easy to go on with these discussion under our belt. So limit x tends to 1 minus, limit x tends to 1 plus. We are going to check at 1 because it is already said that the function is continuous and differentiable. So when you go on the left, remember I just told you, when you are on the left of 1, just a bit left of 1, you have to use ax square plus b. I am doing the continuity right now. When you are on above 1, that is x is greater than equal to 1, you get 1 by x. Right? So x is greater than equal to 1, you will use 1 by x. Right? Now, if you see, if I apply x limit 1, I am not getting any value which is division by 0 or any value which is undescribable, indeterminate or not found or not defined, nothing like that. Because the values which are undefined are especially those which are divided by, you get a division by 0. So ax square plus b 1 by x, I am applying 1 directly here. In place of x, I am replacing it by 1 or putting 1 in place of that. So a plus b and 1, when you know that it is continuous, a plus b equals 1 because the left hand limit and right hand limit are equal. So first equation is a plus b equals to 1. Okay, I am clearing it again because we are talking about the differentiability now. A plus b equals to 1 is the first equation that we are going to use just now. At x equals to 1, now we are gearing up for the differentiability. Fx minus fc divided by x minus c and limit x tends to c. C is 1 here. What is 1? C, 1. F1 is what? Please remember, I told you the equality also. It was 1 by 1, 1 by x. So if you replace x by 1, it will be 1 by 1, that is 1. So in place of f1, we are going to put 1. So this actually function, which is the differentiability function, fx minus 1 divided by x minus 1, this is the simplified version we are going to use. So we'll go to the left hand derivative, we'll go to the right hand derivative, and we have used fx on the left hand limit as ax square plus b, that we are going to use here also. On the right we have used fx as 1 by x, we are going to use it here also. So I hope you got the idea. LHD and RHD, that means on left of 1, on right of 1, on left of 1, fx becomes ax square plus b, minus 1 was already there, divided by x minus 1. On right, what do you get? See, limit x tends to 1 minus and limit x tends to 1 plus have to be written by you. And when you go on 1 plus, you have 1. So 1, this is 1 by x minus 1 divided by x minus 1. So let us resolve them and try to find out another equation. So in order to solve this, you don't get anything to get it cancelled by x minus 1. So we'll use this a plus b equals 1. In b minus 1, it will be negative a. A plus b equals 1, that means b minus 1 equals negative a. So in this b minus 1, we are going to replace it by negative a. Okay. So let us put it here, b minus 1, you just replace it by negative a. So ax square minus a divided by x minus 1. You can take a common, x square minus 1 divided by x minus 1. A into x minus 1 into x plus 1, it is equivalent to a square minus b square. So you have a minus b, a plus b divided by x minus 1. X minus 1, x minus 1 get cancelled. You have a into ax plus 1. Now limit extends to 1 or was already there. You can apply the limit. You can replace x by 1. So a into 1 plus 1 is 2a. Left hand derivative have given you 2a. On the right hand derivative, you have 1 by x minus 1. So it will be 1 minus x by 1 divided by x. So you have 1 minus x divided by x, and here you have x minus 1. You can cancel 1 minus n x minus 1 because you will get a negative 1. Because these are not same. You have to have multiplication by negative, then only you will get it. So you have a minus 1 by, see, this x minus 1 by x you will get. So minus 1 by x, now apply limit extends to 1. In place of x, replace it by 1. You get 1 by negative 1, that is negative 1. So what do you get? Negative 1. Now as the question is saying that it is differentiable, so the left hand derivative and right hand derivative will be same. So 2a will be equal to 1. A will give you negative 1 by 2. Minus half. Now a plus b is equal to 1. So you can just replace a by negative half in this. A minus half plus b is 1. 1 is b is equal to 1 plus 1 by 2. That is going to be 3 by 2. B is 3 by 2. This is your option. The second option is the correct option. Okay. So this is how you are going to solve it. This is a bit tricky question. If you understand 1 by modulus x, all these, it will be easy. Now this question also we have covered, and you can just go back to the other exercises of this chapter and you will be able to find this question. Because it is not going to take a lot of time, so I can give you one more explanation. So you just have to think that this greatest integer function will always give you the value which is the least integer. That is, and please remember there is one more function which is the lowest integer function. You have a ceiling and floor like that. These functions are nothing but ceiling and floor only. So you have x minus greatest integer function. I will call it as GIF. So this, if you have n and n minus 1, I'm just trying to show you how graphically you can understand it. So if I make a line and you are between 2 and 3, the GIF function will always give you the lower integer. Okay. If you are between negative n minus 1 and n minus 1 and n are not included because n minus 1 is included here. N is not included. So if you are between 2 and 2.999 something, you will always get 2. So x minus modulus of x, if you are between n minus 1 and 1, that is 2 and 2.999 and something, you will always get 2. How do you get this? The GIF function will give you n minus 1. That is 2.3 will give you 2, 2.6 will give you 2 like this. So x minus n minus 1 you can write. Right? So 2.2 will give you 2, 2.6 will give you 2, 2.99 will even give you 2. But when you are between n and n plus 1, assume now you are between 3 and 4. And 3 is included always. So when you are between this, if you are between 3 and 4, n and n plus 1, then what value you are going to get? Again 3. The same logic goes. If you are between 2 and 3, you will get 2. If you are between 3 and 4, you will get 3. So if you are between x is between n and n plus 1, you are going to get the GIF function as n. This one here. X minus n, sorry. Now when you are exactly at integer, the x and modulus, the GIF function will be same. X is also n. The greatest integer function will also give you n. N minus n is 0. Right? So you will get a 0 here. Right? Now, all these are clear now. So let us take the left hand limit and right hand limit and check it at certain n now. left hand limit, right hand limit, check it at n. And you have to put x as n, right? So x minus n plus 1, this is what you have to use in left hand limit. Right hand limit, you have to use x minus n, as I told you right now here. You are checking at n. So x minus n plus 1, if you apply the limit x tends to n here, on the left you will get n minus n plus 1, that is 1. On right you will get n minus n, that is going to 0. So 1 and 0, LHL is giving you 1, RHL is giving you 0, that is not equal. So this function is not continuous. You will not even talk about differentiability because it is already saying that it is continuous, not continuous at integer points. But what about non-integer points? At non-integer point, it will be continuous. We have checked at x equals to n. But when you check at some value that is 2.2, 2.3, 2.8, then you will get the left hand and right hand limit as same. Okay? So if you remove 2.2 minus 2, you will get 0.2 here. On the right also, if you do this, you will get a 0.2. So if the function this is only continuous at non-integer points, it is discontinuous at integer points, because in non-continuity I showed you at x equals to 1. But because of the function of this GIF function, greatest integer function, it is very clear that it is continuous at non-integer points but discontinuous at integral points, which is n, which we have showed taking x equals to n. 1 on the left hand side we got 1, on the right hand side we got 0. Okay. So I hope you got the idea of this. If you want to learn more, then we have already discussed it in the previous exercise. So you can just have a look. This fx is ax square plus 1 when x is greater than 1, and we have to check the derivability at x equals to 1. When x is less than or equal to 1, it is x plus 1 by 2. Right? For those who want to do by themselves, they have a reference here. That is the answer I am showing. And derivability is, that means we have to do the left hand derivative and right hand derivative, and since it is already given that it is derivable, so we can just equate the LHD and RHD. So in order to understand this, this is 1 where the point of contention is, where the graph is supposed to be changing. So this 1, you go left, you go right. When you go left, you will take x plus 1 by 2. When you go right, you will take ax square plus 1. Okay, on the right hand side, ax square plus 1 is the function. On the left hand side, x plus 1 by 2 is the function. So we'll place 1 minus h on the left, 1 plus h when we are taking the right hand derivative. So LHD and RHD, because we are checking the derivability. So this LHD, RHD. So the functions, the actual function, which is fx minus fc by x minus c, limit x tends to c. So c is 1 here because we are checking at 1. f1 is what? Where is the equality? It is here. This is the equality. So we have to put this 1 in x plus 1 by 2. So 1 plus 1 by 2 is 3 by 2. f1 is 3 by 2. So this fx minus 3 by 2 and divided by x minus 1. This is a simplified version which I made, and we are going to put fx depending upon left and right what we are taking. Here the fx has to be put what? If you go to the left, it is x plus 1 by 2. So limit x tends to 1 minus, that is on the left. This 1 minus represent you are going to the left of 1. A bit number, a small bit which has to be deducted. So x plus 1 by 2 we are going to use. 3 by 2 is already there. Denominator is x minus 1. I am also writing this the right hand derivative, but I'll just take it in a short while. So ax square plus 1 is the function we are going to employ, and x minus 1 in the denominator. Okay, half minus 3 by 2 is what? It's minus 2 by 2, that is going to be negative 1. So what we get here is half minus 3 by 2 is negative 1. So x minus 1 here. Now x minus 1 in the numerator, x minus 1 in the denominator, it gets cancelled out. So you'll get a 1. So you get a 1 if whether you want to put 1 minus h or whichever value, because it is a constant function now, 1 you are getting, so you don't have to worry about the value will be 1. So left hand derivative has given us a value after putting or without even putting the 1 minus h, taking the function, this we got as 1. Now left hand derivative we have already taken and that has come to 1. Now coming to the right hand derivative, and if you remember fx minus 3 by 2 divided by x minus 1, that was the simplified version I told you. This is minus 3 by 2. So fx on the right, when you have x greater than 1, so on the right you are going to take ax square plus 1. So we'll put x as 1 plus h, the way we were trying to put 1 minus h, but it was of no use. So on right we have to put 1 plus h, ax square plus 1 minus 3 by 2. So limit x tends to 1 plus it is. In the denominator we have x minus 1. So in place of x, replace it by 1 plus h. And then limit h tends to 0. You have a. In place of x, put 1 plus h whole square. So 1 minus 3 by 2 is, this is going to be negative half. Okay. X minus 1, so 1 plus h minus 1, this gets h. Okay. Now this if I open it, just to give you an idea, if I just open it, a 1 plus h whole square, that is a is a square plus b square plus 2ab, 1 plus h whole square is this. So you get a into ah square plus 2ah and minus half it is, and divided by h. So can you take anything common? No, nothing, because h is in the denominator. So if you put h as 1 here, because no, you cannot put it as 1, you have to put it as 0. But you know a left hand derivative, right hand derivative has to be equal, so it has to be equal to 1. Now open this, a plus ah square plus 2ah minus half divided by h is equal to 1, limit h tends to 0. I am taking h on the right hand side because now the LHD has to be equal to RHD. So a plus ah square plus 2ah minus half is equal to h. Now we already have limit h tends to 0 on both the sides. So you can just apply the limit here. This also holds true, limit h tends to 0. So you have a plus, here it is 0, then 2ah is 0, minus half, and this h is 0. Now what do you get? After applying the limit, a minus half is equal to 0, so a is equal to half. So a will be 1 by 2, then this will be derivable at x equal to 1. This function, see, x minus pi, this is a greatest integer function, and greatest integer function always give you the floor value. And we have already talked about this sine theta and a constant function. We know that both are continuous and differentiable everywhere, but where they are not, let's see where they are not, or whether they will be continuous and differentiable. So anything divided by 0 is not of our use, it is undescribable. We don't take this as an option for the continuous and differentiability. So anything should not be dividing by 0 at any cost. So we have to consider the denominator more, you can say, with more observant attitude. This numerator you already know, sine theta, when theta will be equal to 0, when it is equal to n pi. So what is given here? X minus pi into pi, and x minus pi is the greatest integer function. So this is n pi, and when you just cancel this pi, you'll get x minus pi equals n. Okay, so x minus pi equals to n. So the value of x minus pi will always be some n, right? And this n, I am saying that this is an integer. N pi is integer only. X minus pi is integer. So this is x minus pi is n into pi. The only thing when it is going to get 0 is these points. Okay. So there is no problem here. But the denominator 4 plus greatest integer function whole square should not be equal to 0. So greatest integer function will always give you a value which is integer, because this graph, let me make it a correct graph, 0, 1, 2 like this. This is a number line. Always the greatest integer function will give you an integer value. That is, it will always be some value here as an integer, 1, 2, 3, minus 1, minus 2, minus 3. But this is square, in question it is square. So when you square negative 1 whole square, you'll get 1, you'll get negative 2 whole square as 2, right? So you'll always get a value minimum as 0, and more it goes up to infinity, all the integers. So minimum is 0. So this will be, this cannot be 0 at all. In order to get 0, you have to have this greatest integer function as square as negative 4, and that is not going to come at all. Never, because it is square of a negative number. So it is, the fx is a constant function, it is continuous and differentiable everywhere. Let fx is equal to a plus b into modulus x plus c into modulus x to the power 4, where a, b, c are real constants. Then fx is differentiable at x equals to 0 if. So the differentiability already given, the fx is differentiable. So you can do it by yourself. You just have to take the left hand derivative, right hand derivative, just equate it, and by equation you will get some value of b or a, whichever is there. Modulus x, we already know it is x when x is greater than or equal to 0, negative x when x is less than 0. So this function, you can just say that when x is, because we have to check at x equal to 0. So when x is greater than 0, you are going to get some value. What value you are going to get? All the modulus x you have to put as x or positive x. When you have x less than 0, then what you are going to get? All the modulus x will be negative. So a minus bx. But since it is modulus x to the power 4, the third term, it will be positive, not negative. I hope you got the idea, because the power is 4. Even power will always give you a positive value. Positive, negative will be positive then. So left hand derivative and right hand derivative we are going to find out. So I'll just make the function simplified. Fx minus fc by x minus c is our actual function for the derivability. So fx minus fc, we have to check at x equals to 0. So x is 0 minus h here, that is negative h. X is 0 plus h on the right. So you can write it as h. So fc is what? Where is the equality? This one. A plus bx plus cx4. So f0 will be a plus b into 0 plus c into 0 to the power 4. So you will get an a here. So this function becomes fx minus this a divided by x minus c. So we have to check it as 0. So c will be 0. So divided by x. So fx minus a by x, this is what we are going to use. This is a simplified version. When you are on left of 0, you are going to use a minus bx plus cx4 minus a divided by x. On right, you have to use a plus bx plus c x to the power 4. And that is subtraction of a divided by x I am writing. But now I will put x as negative h on the left and positive h on the right. So limit x tends to 0 minus here, limit x tends to 0 plus here. So this is only showing that where we are going, on the left or the right. And then we have to equate it also. So just put the equality in between these two, because they are equal. This function is differentiable at x equal to 0. So this limit x tends to 0, I am putting x as negative h. So a into minus b minus h plus c into minus h to the power 4 minus a divided by x is negative h here. Just replace it by negative h. On the right, we get limit h tends to 0. Again, just replace x by h. So a plus bh plus ch to the power 4 minus a divided by h. Right? Now, since the function is differentiable at x equal to 0, which is already given in the question, so this h you can cancel. You have equated now. And now you can just apply the limit. Limit h tends to 0, you can just apply. So you get a minus minus become plus bh. Minus h to the power 4 is plus h. So it will be ch to the power 4 minus a. is equal to, this is a negative outside, okay? We have a negative here. So we'll just take this negative. So you can have it a negative here, or you can just transfer this negative on the right hand side. It's up to you. We'll just see how does it turns out to be. It's negative a plus, I'm just taking the negative on the right. So minus a minus bh minus ch4 minus a. So I multiplied this negative which was on the left on the right. You can do either ways. You can multiply this on the left also. So now apply the limit. I'm not writing it, limit x tends to 0. You are applying the limit now. So this minus a plus a, this gets cancelled. Now bh plus ch to the power 4 equals minus bh minus ch to the power 4. You can take h common. You get b plus ch cube. Then on the right you can take h common. So you have minus b and minus ch cube. This h gets cancelled. Now apply the limit now. As I am saying, limit h tends to 0 is already there. So wherever h is there, that term you can cancel out. I'm applying limit h tends to 0 here also as well. You are left with b here, you are left with negative b here, b minus b. So you can take 1b here, 2b equals 0, b is equal to 0. So this is your answer, b is equal to 0. Now this question is a bit tricky. Why? Because there are various solutions available, and some of them they have given different discussion, and modulus 3 minus x is quite easy to understand. You have already done a question like this. But here we have a least integer function. So you are talking about the ceiling. The greatest integer function tells you the floor. The least integer function will tell you the ceiling. But the problem here is all the solution they have considered this x only as x round x, means the greatest integer function of x, but it is not. The greatest integer function is 3 plus x. The whole is 3 plus x. Then we have a round bracket, and that round bracket is suggesting it is a least integer greater than or equal to x. Okay. So we'll put x as 3 minus h and x as 3 plus h. What we have been doing, we have to check at x equal to 3 because all the options are at x equal to 3. So x equals 3 minus h on the left, x equals 3 plus h on the left. So we have this 3 minus h, just replace this wherever x is by 3 minus h. So we have plus, this is 3 plus x, so 3 in place of x, just replace it by 3 minus h. 3 plus 3 minus h. But remember, this round bracket is not a simple round bracket. It is a least integer function. Now limit x tends to 0, and right hand also, to check the continuity, we'll just check it. So we just have to put 3 minus in place of x, put 3 plus h, and plus here again 3 plus x. So in place of x, replace it by 3 plus h. Please remember, in the greatest integer function, you always, whichever is between n and n plus 1, you'll always get an n. But when it is greater than or equal to, that means the least integer, you'll always get n plus 1. So this 3 minus h will be what? 3 minus 3 plus h, 3 gets cancelled, you have h here. So modulus of h plus 6 minus h. And this is, you can put a square bracket, you can put a round bracket. On the right you get limit h tends to 0, 3 minus 3 plus h. So you get negative h here, negative h modulus. And you have this 3 plus h. So 6 plus h you'll get. Okay. Now, you can apply the h tends to 0 easily at the modulus function. That we have already seen. Modulus of 0 here and modulus of negative 0. This is quite easy to contemplate. But this least integer function, we cannot put h as 0. Why? Because 6 minus h will give you something, and we have to take the least integer function of that value. That is, you are at 6. You are subtracting something from 6 minus h. So it will be the least integer function will always give you a higher value. Okay. So this 6 minus h will give you 6. And I've written this 5 as wrong. It is going to be 6, sorry. So there is a slight mistake here. You will get as a 6 here. And on the right, 6 plus h, of course, 6 plus something h will take you to 7. So 6 and 7 is not equal. Please remember, 5 is wrong here. I am saying it to be 6. And why 6? Because you have subtracted something from 6, it will always go to 6. You add something to 6, it will always go to 7. So 6 is not equal to 7, and since it is not continuous, it will not be differentiable. Okay? I hope you got the idea. See, if you have to do this 2 to 3 and 3 to 4, you put something which is lower than 3, that is 2.9, just higher than 3, that is 3.1, the concept remains the same. So rather than doing this as 2 to 3 and 3 to 4, or x less than 3 and x less than greater than 3, the better way is to directly put the way I showed you. And there is a slight correction here which I am just reiterating. It is not 5 on the left, it is 6. Okay, it is 6 on the left and 7 on the right. And 6 and 7 are not matching, so it is not continuous. But it is differentiable, but it is not differentiable since it is not continuous. You have to have continuity to get the differentiability. Okay, so it is not continuous. You can just say it is not continuous, not differentiable as well. This is how we understand. Again, I'm sorry for this 5, this is 6. So in order to solve this question, there is one thing which you need to keep in mind. There's only one catch here or hack here. E raised to the power 1 by x it is. So if x is 0, e raised to the power 1 by 0 is infinite. Anything divided by 0 is a very huge number. We don't know that. So e raised to the power infinity, because e is 2.72, like that number, e is, we know it has a proper value. So that to the power infinity will be infinity. Infinity is a very big number. So we will put x as 0 minus h on the left, we will put the x as 0 plus on the right. So continuity, in order to check, let us see, we will put x as negative h, we will put x as positive h in this function. So 1 by 1 plus e raised to the power 1 by x, and I am directly writing minus h because we know what are the steps, what you are going to write. I'll show you the solution also so that you can try it yourself. So limit h tends to 0 on the right, so you will get h in place of x. So e plus 1 by h, 1 plus e to the power 1 by h. So 1 plus 1 by e raised 1 by minus h. See, x to the power minus 1 is what? 1 by x. So e raised negative 1 by h can be written as 1 by e raised to the power 1 by h. So 1 by 1 plus e raised 1 by h. Now when you apply h as 0, 1 by e to the power 1 by 0 is what? Infinite. H is 0, so 1 by 0 is infinite. E raised infinite is what? Infinite. So what do you get here? 1 by infinite. E raised 1 by h, as I told you in the earlier, when I started this question. Here again h is 0, so e raised 1 by 0 is e raised 1 infinite. So 1 by 1 plus e to the power infinite is infinite only. So 1 by infinite is what? If you divide 1 by infinite number, it is going to be 0. So 1 by 1 plus 0 it is. So it is going to be 1. So this, when you add anything to infinite, it is going to be infinite only. So 1 by infinite is going to be 0. Again, if you divide anything by infinite, it is going to be 0. So on left you get 1 by 1 plus 0, that is going to be 1. On the right you get 1 by infinite, that is going to be 0. So the left hand limit is 1, right hand limit is 0. They are not matching. So the function is not continuous at x equals 0. So when there is no continuity, there cannot be any differentiability. Alright. So discontinuity does not correspond to differentiability. So this is a solution which I want to highlight. There are certain people who want answers. There are certain people who say, oh, you are showing the answer, you are solving it. What is the fun? So, both the audiences I have to uh, feed them. So this is how it turns out to be. You have 1 and 0, so you don't have to check the differentiability. This is an MCQ question. When the function is not continuous, why would you go for differentiability? You don't have to do. Unless and until you are specifically asked, okay, check the continuity and differentiability, then you will do the differentiability. If this question comes in that kind of situation, then you have to do the differentiability that I have already showed you. But if you write that if the function is not continuous, it cannot be differentiable, the examiner will understand. So this is fx, 1 minus cos x by x sin x when x is not equal to 0. And when x equal to 0, it is half. At x equal to 0, we have to check for the continuity and differentiability. So those who wants to themselves, for them I have given a reference. So it is subjective. Sometimes people do like this, but I'll give you another way to do it. So if the function is continuous, that means it may be differentiable, non-differentiable, but a function is differentiable, that means it has to be continuous. The reverse is true. Now x equals to 0, we will check for the left hand limit and the right hand limit. In the left hand limit, x is equal to 0, so we will put x as 0 minus h, that is negative h we are going to put. X as 0 plus h, that is h we are going to put. And we'll use this function because there is no two different function for the same. So limit h tends to 0, 1 minus cos x by x sin x. So this is going to be 1 minus cos, in place of x write minus h, divided by x is minus h, sin minus h. Here also the same thing, 1 minus cos h divided by h sin h. Now please remember, cos negative theta is equal to plus cos theta, and for the same sin negative theta, it's going to be negative sin theta. Sin minus theta is minus sin theta. For cos, it is not like that. So in the numerator, it will be 1 minus cos h only. In the denominator, you will get negative sin h. Since we have a negative h already there, so negative gets cancelled and you get h sin h. Now coming on this side, 1 minus cos h by sin h. Now you see the left hand limit and right hand limit are exactly similar. So I will solve one of it and you will know what will be the other RHL if I just solve this LHL. Because both results are same. We have come down to the same result. So what will be the result? You can have a reference on the right. You can say that people have solved in different ways. But 0 cannot be, we cannot have or we cannot afford to have a 0 in the denominator. That is very true. So we can do it like that, the way people have suggested. So what I will try to here is 1 minus cos h is 2 sin square h by 2. That means 1 minus cos theta is equal to what? It is 2 sin square theta. 1 minus cos 2 theta is 2 sin square theta. So this is 2 sin square h by 2. This is h already there. Now you need h square, so I am putting an h in the denominator, so I have to put have a h in the numerator also. So sin square h by 2 it is. So we need a 4 here also, so we need to have a 4. We cannot just introduce value like that. You have to have a cancellation also. So for now we have sin h also. Okay. Now we know most of the results. This is sin h by 2 whole square. This is sin theta by theta whole square. And we know that sin theta by theta is 1. 2 by 4 will give you half. And this sin h by h by sin h or sin h by h, they are similar. When you apply the limit h tends to 0 for sin theta by theta is equal to 1. So this sin theta by theta is going to be 1. So this is 1. When we apply the limit, this is also 1. Okay. Both ways, both are will follow the same rule. So what is remaining is half. So these are different solutions being provided, and internet you will find number of solutions there. But this is the best solution what I can give you, because both the values are half. When both are half, the left hand limit and right hand limit are similar, they are equal. So when the left hand limit and right hand limit are equal, that means you can say this function is continuous. Continuity we have checked. This function is continuous. Not continuous you can cancel out. This will just check. Not continuous, so this also we can cancel it out. So we have first and third one. Continuous and differentiable. Continuous but not differentiable. So we will check the differentiability just now. We have completed the continuity part. So we will, there is a trivial method of putting 0 minus h and 0 plus h like that. What we'll do here is limit 0 extends to 0 minus, limit extends to 0 plus. So we'll just try to simplify this question. Fx minus fc divided by x minus c it is. Limit x tends to c. Now c is 0 here. It is x equal to 0 we have to check. So x is not equal to 0, so we have to use 1 minus cos x by x sin x. So fx minus fc, what is fc here? F0 is given as half. This value is already given as half. So you can just put half in place of fc. Now x minus c is what? 0. So you can just have x. So final function will be fx minus half and divided by x. The same thing on the right also. That is the left hand derivative and right hand derivative. So what you can do here is, this is 1 minus cos x by x sin x, that you have to put in place of fx, minus half divided by x. Now you can apply the limit, that is 0 minus h, 0 plus h you can use, but you'll see you won't require it. I'll just show you how you can get it done without using that. In the first part when we were checking continuity, I told you 1 minus cos x is 2 sin square x by 2, x sin x was already there, so you can have x square by 4 and 4 in the denominator, x in the numerator, because you have introduced x square by 4. So this sin square x by 4 and x square by 4 will give you 1, and sin x by x will also give you 1, right? So this sin x by x will also give you 1, this 1, and 2 by 4 is half. So 1 by 2 minus half divided by x. Same thing here. There is no change because we are using the same thing. Ultimately, you have to replace x by 0, but we will not replace it by 0 because see, 0 is in the numerator. We'll just call it as it is 0 by x or 0. We cannot say it as, if you put 0, this h, remember, if you put h, you have to put h as 0, but here we have not used that. The set of points where the function fx is given by this is differentiable, and we'll just check the differentiability. We'll not go for the continuity because the question is only asking about the differentiability. So the set of points where the function fx is given by this modulus of x minus 3 cos x is differentiable. Now how do we check where we have to, what is the point we have to check? This is for the differentiability of x minus fc by x minus c, limit extends to c. Modulus of x minus 3 is 0. So x is equal to 3. So we have to check at 3. This is how we get the point. Okay, we have to use the value which is given in the question, not like just like that. So 3 has come just because modulus x minus 3, that is x minus 3 is going to be 0 only when x is equal to 3. Right? So we are going to check at 3. So what is the f3? We'll just see what is the value of fx. But f3 we need to know. f3 is what? Modulus of 3 minus 3 cos 3. Modulus of 3 minus 3, it is going, cos 3 will always be a value between negative 1 and 1. You know, cos and sin always oscillate between negative 1 and 1. This is the highest and lowest value of cos and sin. But modulus 3 minus 3 is 0. Modulus of 0 is 0. So you get a 0. So this FC, F3 we are going to put as 0. So this FC can be eliminated. Denominator you have x minus 3. So the simplified function which I made is fx minus this fc is going to be 0 as I just told you. Fx, fc is 0, x minus c, so x minus c is what? 3. So fx divided by x minus 3. Alright. So we'll put x as 3 minus h on the left, we'll put x as 3 plus h on the right. So limit x tends to 3 minus, you can write. Here you can write x, limit x tends to 3 plus. Okay. This x minus 3, on the left of 3, you will get negative x minus 3 when you open this modulus. This is a modulus. So when you open this modulus, it's going to be negative on the right. On the right, it is going to be positive x minus 3 because it is modulus. You have to open it anyway. But what value and what value where you are going to get, that can be computed and that can be known at x equals to 3. Because modulus x is x when x is greater than or equal to 0, it is negative x when x is less than 0. Not less than or equal to 0, it is less than 0. So there is a correction, slight correction there. So this is what we are going to put. When we go on the left, we are going to replace the modulus x minus 3 by negative x minus 3. On right, we'll replace it by positive x minus 3. Alright? So this left-hand derivative and right-hand derivative, and we'll just see whether they are equal or not. If the LHD and RHD are not equal, we'll say it is not differentiable. So I'm replacing negative x minus 3, cos x remains like that, we'll replace it by x by 3 minus h in a short while. On the right, it is going to be x plus 3, positive x plus 3, because we have opened the modulus, and this cos, in place of x, we'll put x only, and the denominator you have x minus 3. So you have x as 3 minus h in the left and x as 3 plus h on the right. So 3 minus h is minus, x is 3 minus h minus 3, and this is going to be cos 3 minus h divided by x minus 3, x is 3 minus h minus 3. Here also the same thing, x replace it by 3 plus h plus 3, and this is going to be cos 3 plus h, and denominator you have 3 plus h minus 3. Now this limit and h tends to 0, all you have to write in all the steps, okay? I'm just skipping it just to make it faster. 3 plus h minus 3. So this gets cancelled, 3, you have a negative h. There is already a negative outside, so it's going to be positive h. Cos 3 minus h divided by, you have 3 gets cancelled. You have a negative h here. A negative h is this one, okay? On the right, we have this x minus 3 it is. So there is again a slight change here. And to err is human. That what you can take from this. Okay, h cos 3 plus h divided by 3 gets cancelled. You have a h in the denominator. This gets cancelled. This also gets cancelled. Cos 3 minus h. It is negative cos 3 minus h. Here we have cos 3 plus h. Now, if whatever you put inside cos, it is going to be negative 1 or 1 value, right? So you can just have h as 0, cos 3 will have certain value, we don't know, but we don't require it because we have known that it is cos 3 will be some constant value, negative constant, cos 3 and plus cos 3. So they are not equal. That is, this function is not differentiable at x equals to 3. So you have all the real number except 3. That is what you are going to tick, the second option. Let fx equals, so we have 3 intervals here, and we have to check the continuity and differentiability at these points. So is it continuous everywhere, differentiable everywhere, or they are just, this function is only continuous and differentiable at negative 1. So we'll check the continuity and differentiability here, alright, and this we will follow the trivial rule. That is the traditionally what we were doing. We'll just do that. X equals to negative 1. So on the left we go. So when we go on left of minus 1, I'll just show you what we are going to take. When we go to the right of negative 1, I'll just show you what we are going to take. So this is your, see, I'll show you in the number line. We have this negative 1, we have a 1 here. And in between negative 1 and 1, we'll use modulus x. When you go to the left of negative 1, you'll use 1. And when you go on the right of 1, you are going to use 0. So at x equals minus 1, we are going to check. When you go on left, you will take a constant function which is 1. So if you are going to check at x equals -1, you have to put x as -1 minus h. On the right, you have to check -1 plus h. That is what we do normally. We subtract h and we add h on the left hand limit and right hand limit. And when we have this x equals to -1, what we get? Only 1, because x is less than or equal to 1, it is 1. It is a constant function. Only one value is there. So all these you have to write, right? X tends to 1 minus, right? On the right, you have to write x tends to 1 plus, that you have to write, limit h tends to 0, that all you have to write. Okay, I'm just skipping all these. I don't write it, so you have to just follow my instructions and you have to write it in all the steps. Okay, now on the right, what we'll get? -1 and greater, you will get a modulus x. So modulus x, it is just put -1 plus h. So when we apply the limit x tends to 1 plus, you'll write modulus x. When we apply this limit h tends to 0, you can just put h as 0, and it will be modulus -1. This is 0. Modulus of -1 is going to be always a positive value. Modulus will always give you a positive value. So left hand limit and right hand limit, you see they both are 1. When they both are 1, that is, the function is continuous at x equals -1. So this is the first thing what we get. Now we will see for the differentiability. If the function is not continuous, we cannot go ahead for the differentiability. So we'll check for the differentiability now at x equals to -1 only. And same point and same results we will discuss. X equals to -1, LHD, RHD, left hand derivative, right hand derivative. X will be -1 minus h, x will be -1 plus h, depending upon you are going on the left or the right. So this is, when you go on the right, you have to use modulus x. When you go on the left, you have to use a constant value, constant function, that is 1. Okay, the function same is different now. Fx minus fc by x minus c, that is what you are going to use for limit x tends to 0. This limit x tends to c in this case. So f minus 1, because fc is basically f minus 1. What is f minus 1? When you put -1, what is the equality sign? It is going to be 1. Equality sign is in the first. X is less than or equal to -1. So equality sign is with -1. Is 1. So f -1 is 1. In place of fc, you will just replace it by 1. And this fx on the right of -1, we will replace it by modulus x. When you go on to the left of -1, in the same way we have done in the continuity, we will replace it by 1. X minus, and this c is -1, because we are checking at -1. So x minus of -1, that is x plus 1. Okay. So the simplified function we will use for LHD and RHD is fx minus 1 divided by x plus 1. So you just have to replace fx first. For that case, you will write limit x tends to -1 minus, and limit x tends to -1 plus. So 1 minus 1 divided by x plus 1. On the right, you are going to use what? Because fx we have replaced by 1 on the left hand derivative. Right hand derivative, you have to replace it by modulus x. Modulus x minus 1 by x plus 1. Okay, modulus x minus 1 by x plus 1. Now 1 minus 1 is 0. Even if you want to do something, you can just have this -1, minus h, all those stuff you can replace. If you want to put this -1 minus h and -1 plus h on the left and the right, this you can replace. So you have limit h tends to 0, 1 minus 1 divided by x plus 1. X is -1, h plus 1. This, now it's up to you. See, 1 minus 1 is already 0. And the denominator, whatever we get, just see on the, we'll just show you the right hand derivative also. So if you want to put this h, you can put, but I will advise you not to put this -1 minus h or 1 plus h. So in the left hand derivative, right hand derivative, you don't require to have h, as I showed you in one of the question in the earlier discussion. So modulus x will be -1 modulus minus 1 x plus 1. I am not replacing it by this -1 plus h. So you will get modulus of -1 is 1. 1 minus 1 by x plus 1. So you have here, I am not replacing it by h. So it is -1, 1 minus 1 by x plus 1. And in the right hand limit also you have 1 minus 1 by x for 1, x plus 1. So left hand derivative and right hand derivative are equal. You don't have to worry about what is going to come. In some certain questions you have to worry about, oh, this is going to be infinite or some indiscriminate value, but you don't have to worry about this because the left hand derivative and right hand derivative are coming same. When they are coming same, it's safe to say it is differentiable at x equals to minus 1. So as I'm saying, I showed you negative 1 minus negative h and negative 1 plus negative 1 plus h. You don't have to put that, okay? In actual solution, don't put that. Just go along with x plus 1 and the way I showed you in one of the question earlier, just a few minutes back. So differentiability at x equals to minus 1 is your answer, because continuity means you can check for differentiability. It can be differentiable, it cannot be differentiable. But once it is differentiable, it will be continuous. So this fx equals to sin x function. So this is the question number 12 of exercise 10.2. We have already discussed this in detail. But there is a question coming which is dealing with the modulus of cos x. So when you have modulus of cos x, you have to understand what will be the modulus of sin x. So when we discussed everything about sin x, modulus of sin x, we knew when it is going to be negative, when it is going to be positive. In MCQ, you just have to check one of the option. So if you want to see how this gets solved, there is a solution which I have already explained. But because you see this graph, and in this graph it is very clear that when you have a sin x, this is a function. Modulus of sin x, that means there will be nothing on the negative y-axis. Because modulus x is modulus of anything will always give you a positive value. So these below crest or trough, whatever you call, this is going to go up. This will be removed. This will be eliminated. So when you check the continuity, you know that there is a way and there is no breakage. If you can draw something without picking your hand from the paper with the pen, this is continuous. So sin x, modulus sin x is already continuous, which you see here. How about the differentiability? Differentiability means there should not be any sharp edge. There should not be any sharp turn. If it is like that, the function will not be differentiable. But here you see at negative pi, at 0, at pi, at 2 pi, there we have a very sharp turn, sharp edge. And sharp edge simply means non-differentiability. So you have pi, 2 pi, negative 2 pi, you can just call it as n pi. So at n pi, n is basically integer here, because 1, 2, negative 1, negative 2, all these are integers. So when you have n belongs to z or the n pi, this sin x is going to give you a continuity, but no differentiability at x equals to n pi. Okay. Now fx equals to modulus of cos x we are doing. X equals to modulus cos x, the same thing what x equals to modulus cos x, same discussion as modulus of sin x. Now this function is actually showing you cos x. Cos x function is simple, that you can draw just like sin x, but the negative part will not be there. There will be no negative part. Okay, all the part which are in the negative y-axis, that has to be taken up. That is, all lines which are below the x-axis, they have to go up like this. There will be nothing on the negative y-axis, because modulus always give you positive y-axis, the value on the positive y-axis. Now there is no break here. You just see there is no break. Same way we discussed the sin x, there is no break. But these points, they have very sharp edge. When they have continuity means no breaks. But this differentiability means there should not be any edge. But here we are at pi by 2, 3 pi by 2, negative pi by 2, negative 3 pi by 2, all have the edges. And since we have sharp edge, that is, you can generalize it taking the integer 2n plus 1 pi by 2. 2n plus 1 is simply the odd number. So 2n plus 1 pi by 2, this shows that all these points are going to give you the sharp edge, and sharp edge means no differentiability. So this function is continuous because there is no break, but this function has, this modulus of cos x has sharp edges at 2n plus 1 pi by 2, so it will not be differentiable at 2n plus 1 pi by 2. Same discussion goes for sin x modulus also, that we have just discussed. Okay. The function fx equals to 1 plus modulus of cos x. Now, modulus of cos x we have already known. Cos function we know, y equals x, if it is a line, it will pass through origin. When we add plus 1, that means you go up. That is just a 1 point ahead. This is y equals x plus 1. And when we have x minus 1, you are 1 point below. So this is how the function changes. But the actual scene, actual scenario, actual say panorama of the question doesn't change. Similarly, if you know about modulus of cos x, you know the function. Modulus of cos x will always give you positive on above x-axis like the dome shaped structure. So this is a very good drawing by me. Thank you so much. And modulus of cos x will give you what? All these parts will go up. There will be nothing on the negative y-axis. That is the whole idea about the modulus function. So when you add 1 plus modulus x, that is you are just making this modulus cos x go up 1 unit. You just hold this, take it 1 unit up and keep it there. So that is the 1 plus modulus of cos x. Because cos x is going to give you negative 1 and 1 only. All the values will be between negative 1 and 1 always. But when you add 1, that is going to go up. Okay. So this is the line. I'll just show you the line. So this is the line. This is your actual x-axis, y-axis. So this is the imaginary, or not imaginary, but proper line, which is y equals 1 it is. Y equals 1. And then you add a cos x, so you can just add a cos x function here. So this same function cos x which you see will just be shifted up 1 unit. So whole idea will remain same. Mod cos x will be what? Mod cos x is all the value which is below the x-axis will go up. So we talked about cos x, modulus of cos x. It is continuous everywhere, but it is not differentiable at 2n plus 1 pi by 2. That is all the odd multiple of pi by 2, there is a sharp edge. So it cannot be differentiable. So this is how you are going to give answer, okay? Continuous everywhere is the only answer, because not differentiable at x equal to 0. No, it is differentiable. You see at x equal to 0, it is good. It is very good differentiability it is showing. At x equal to n pi also it is going very good differentiability. Only at 2n plus 1 pi by 2, no differentiability. So these all options, only second option which I see is correct. It is continuous everywhere. Okay. These all are wrong. The second option is correct. So this is how this question is done. Okay. Thank you so much. Take care of yourself.